the Algebra Progress Check for GCSE Higher. Factorize 4x squared minus 4x minus 15. There are different methods you could use here, but the one that I prefer is this. So I'd multiply the coefficient in front of x squared with the last term. So 4 times minus 15, which is minus 60. So we'll look for factors that multiply to give us minus 60. And that could be minus 10 times 6, for example, or minus 6 times 10. It could be minus 60 times 1, or minus 1 times 60. Could be minus 30 times 2, or minus 2 times 30, and so on. But I also want these two factors to add up to minus 4. And I've got that already. So minus 10 plus 6 will give me minus 4. So these are the two that I'm after. So I'll open the two brackets. I'll put 4x in both to begin with. And I'll put minus 10 here and plus 6 on the other one. It's definitely not the final answer because, as you can see, we've got 4x times 4x, which is going to give us 16x squared, whereas we only need 4x squared. So we're going to have to rise this further. So looking at 4x minus 10, what kind of factor could I put in front of the bracket so that would make the numbers smaller? So I can definitely put a 2 because both 4 and minus 10 would be divisible by it. So if I had put 2 in front, then I'd have 2x minus 5. But of course I don't need the 2 in front. And here I can do the same. So imagining putting 2 in front, we could have 2x plus 3. Now we've come to a point where 2x times 2x will give us 4x squared. So this is the point that this should work. So let's expand this. 2x times 2x gives us 4x squared. 2x times 3 is going to give us plus 6x. Minus 5 times 2x is going to be minus 10x. And minus 5 times 3 is going to be minus 15. We could simplify this further. So we get 4x squared minus 4x minus 15. So this is the right answer. 2x minus 5, 2x plus 3. In the next question, we've got to multiply 2x minus 1 with x plus 3 and x plus 1. So it's 3 sets of brackets. The way we can do this is by expanding the first 2 brackets and then multiplying with the third set of brackets. Or we could expand the last 2 and then multiply with the first one. Whichever way, that should give us the same answer. So I'm going to expand the first 2. So 2x times x is going to give me 2x squared. 2x times 3 is going to give me 6x. Minus 1 times x is going to be minus x. Minus 1 times 3 is going to be minus 3. So all of this is going to be multiplied by x plus 1. So I can in fact simplify this further to make my life easier. So I'll write it as 2x squared plus 5x minus 3, all multiplied by x plus 1. Now I can multiply each of these terms inside by x. So 2x squared times x is going to give me 2x cubed, and 5x times x is going to be 5x squared, minus 3 times x is going to be minus 3x. Now I can multiply each of these terms by 1, so that is straightforward, which means plus 2x squared plus 5x minus 3. And of course we can simplify this further. We only have 2x cubed, and we've got 5x squared plus 2x squared, so this and this, which makes 7x squared. We've got minus 3x plus 5x, which is 2x, and we have minus 3 at the end. So this is the final version of it, and the question is, what's the coefficient of x squared in the expansion? So the coefficient is the number that is in front of x squared, which is 7. In question number 3, we have the equation x cubed plus 4x equals 101 has one solution which is a positive number. Use an iteration method to find this solution. Give your answer correct to 1 decimal place. So the method that I'm going to use here is a trial and error method, trial and improvement method. So what this is going to mean is that I'm going to kind of estimate which values is the solution between of. Cube numbers, we should know the main cube numbers or the smallest ones. So by replacing x with 3, for example, I'd get 3 times 3 times 3, which is 27. So 3 cubed is 27, plus 4 lots of 3, which is 12, is much smaller than 101. So I'm going to look for another value. If I plug in 5, for example, we'd get 5 cubed, which is 125. So that is higher than 101 already. So probably 4, in between 4 and 5. So 4 cubed, which is 64, and 4 lots of 4, which is 16. So 64 at 16 is 80. So we know that the solution, the positive solution, will be between 4 and 5. We know that the solution will sit between 4 and 5, and we asked to write this correct to 1 decimal place. So we will continue. Now, what decimal is that, which is between 4 and 5, and it gives us a answer very close to 101. So we could go for 4.1, 4.2, 4.3, and so on. So we are actually estimating here. Because 101 is closer to 80 than it is to 145, I'm going to go for a decimal that is 4.3, for example. So again, I'm estimating, I'm guessing. I don't know the actual answer, but I can give it a go. So if x is 4.3, we'd have 4.3 cubed plus 4 lots of 4.3, which is equal to 26.707. So this is close now to 101, but it still is too small. So we're going to try a bigger decimal, such as 4.4. So when x is equal to 4.4, we'd have 4.4 4 cubed plus 4 lots of 4.4, which is equal to 102.784. So this is now too big. However, we only asked to write the answer correct to one decimal place. So our answer would either be 4.3 or 4.4. To decide which one is going to be the final answer, we are going to look at 96.707 and 102.784. Which one of these is closer to 101? And the difference between 96.707 and 101 is about 4.3, whereas the difference between 102.784 and 101 is about 1.8. So as you can see, this one is closer to 101. So we'll write 4.4 as the final answer. In question number 4, we've got, what does a negative slope on a velocity time graph represent? So first of all, what does velocity mean? Velocity means speed. So what we have is a graph where we've got speed here, or velocity, and we'd have time here. So very quick sketch. If you see a shape like this, for example, this would be a flat one. So this part here shows that for this duration of time, speed has gone up, and then it has remained the same for this duration of time, and we can see it going down here. So speed going down. So a negative slope, which is this one, on a velocity time graph represents slowing down, or means slowing down. In the next question, we've got, what does the area under a velocity time graph represent? Let's use the same sketch that we had here of the graph. So let's take this particular area. We've got time, so maybe this was 30 minutes, and velocity being maybe 30 miles per hour or 40, whatever it can be. So we've got as a shape of a rectangle, don't we? And the area of a rectangle is worked out by multiplying length by width. So in this case, the length of it will be the velocity, and the width will be the time. So to work out the area, we multiply velocity with time, or by time. And what does that give us when you multiply speed or velocity with time? I'll use the speed formula. So speed is equal to distance over time. And for those of you who use triangles, we'd have speed here, distance, time. So when you multiply velocity or speed with time, it does give us the distance. So that is exactly what the area under a velocity time graph represents, distance. In question number 6, we've got f of x is equal to x cubed minus 2x plus 3. Find f for a value of minus 2. So we've got to find the value of the function if x is equal to minus 2. So just like an equation, what we're going to do is we're going to replace x with minus 2. So f of minus 2 is going to be equal to minus 2 cubed minus 2 lots of minus 2 plus 3. So minus 2 cubed is equal to minus 2 times minus 2, which is 4, times minus 2, which is minus 8. Minus 2 times minus 2 is 4, so plus 4 plus 3. So minus 8 plus 4 is minus 4, plus 3 is minus 1. So the answer is minus 1. Question number 7, we've got the nth term of a sequence is given by 3n plus 1. The sum of two consecutive terms is 125. Find the value of the two terms. Separate your answers with a comma and put the smaller answer first. So, since we don't know which term this is, the first one or the second one, what we're going to do is we're going to leave n as it is. So that first term of the two can be represented as 3n plus 1. The next one will be 3 times n plus 1, because if this is the fifth term, for example, the next one will be 5 plus 1, so the sixth term. So that's why I'm replacing n with n plus 1. And of course, we shouldn't forget to add 1, which is part of the nth term given. So what this means is that the sum of these two together is 125. So 3n plus 1 plus 3 lots of n plus 1 plus 1, all of this equals 125. So we can expand 3n plus 1 plus 3n plus 3 plus 1 is equal to 125. Collecting the like terms, we've got 3n and 3n to make 6n. We've got 1 plus 3 plus 1, which makes 5. So this is 125. Taking away 5 both sides gives us 6n is equal to 120. So n must be equal to 20. So don't forget, n means the 20th term in this case. So we need to work out the value of the 20th and the 21st term. So the 20th term will be worked out by getting the nth term, which is 3n plus 1, and replacing n with 20. So we've got 3 times 20 plus 1, so that is 61. So this must be the first term that we asked to find, 61. And the next one we can work out by replacing n with 21 if we like. So we go 3 times 21 plus 1, that is 63, plus 1 makes 64. So the next term is 64. We can double check because this is 3n, so that means adding 3 to get to the next term. So, and that works. So 61 and 64 are the two terms that we're looking for. In question number 8, we've got to factorize fully 8x squared minus 18. So by looking at this, we've got x squared and we've got minus 18. So this resembles the difference of squares, but there is another factor in there as well. So looking at minus 18, this is double minus 9, and 9 is a square number. So I'm gonna factorize first this part by putting 2 in front. So we get 2 lots of 4x squared minus 9. Now I'm going to factorize further the 2 terms within the brackets. So if I use the method that I used previously, I can go and multiply minus 9 with 4, which is going to give us minus 36. And 2 factors that would give us minus 36 would be minus 6 and 6. And this is exactly what we're interested in this case, because minus 6 plus 6 would give us 0. And we haven't got a term in between x squared and minus 9. So I'm going to open up the 2 sets of brackets, and I'll put minus 6 and plus 6. We'll put 4x in both of the brackets, and we'll factorize again. So if dividing by 2, this would become 2x minus 3, and we'd have 2x plus 3 on the other one. So expanding this, we get 4x squared and plus 6x minus 6x minus 9. So plus 6x and minus 6x will cancel each other out. So all we're left with is 4x squared minus 9. So I need to remember now to put the 2 in front, and this should be the final version. Question number 9, we've got to make S the subject of the formula. So we've got R equals 3S plus pi S plus 2t. So we want to put S in its own. So I'm going to rewrite this. Plus 2t. Now I can see S in 2 terms in here, so I can actually factorize that. So that would put S in front. 3 plus pi plus 2t. So now we've got to take 2t to the other side first, because BIDMAS tells us that we need to multiply. So S times 3 plus pi would come first, and then you'd add. But in algebra, you reverse in the process, so you're going to have to take away the 2t. So I'm going to do R take away 2t is equal to S times 3 plus pi. And to leave S in its own, we're going to have to divide the other side by 3 plus pi. In other words, we're dividing both sides by 3 plus pi. So we've got S in its own here, and we get R minus 2t all over 3 plus pi. So here we could do it as R minus 2t, because it's a whole thing that is being divided by 3 plus pi. In questions number 10 and 11, we've got to use the quadratic formula to find the negative and positive roots of the equation. 3x squared minus 2x minus 20 equals 0. and we've got to give the answer correct to 3 significant figures. So the first thing to do is to write the quadratic formula, which is minus b plus minus square root of b squared minus 4ac all over 2a. Step would be to identify which is a, b and c. So this, the coefficient between in front of x squared is a, in front of x is b, and the final term is c. So we'll plug in the values. B is minus 2, so minus b is going to be 2, plus minus, so let's do minus first and then we'll do the plus. So 2 minus square root of b squared is 4, because minus 2 squared is 4, and minus 4 lots of a is 3 and c is minus 20, all over 2 lots of 3. So now we can work with the numbers. We get 2 minus square root of multiplication first, so minus 20 times 3 is minus 60. Minus 60 times minus 4 is 240, and 240 is positive, so we'll go 4 add 240, which gives us 244, all over 6. So square root of 244 comes first, and that gives a long decimal, which is 15.62049935. So what we'll do is we'll keep that in the calculator and we'll take it away from 2. And that answer will then be divided by 6, which gives us minus 2.2700832225. Now we've got to write the answer correct to 3 significant figures. So this is the first figure, second, third. So we'll stop here. This 0 tells us that we've got to round down. So we'll keep this as minus 2.27. To work out the positive root, which is the next question, all we have to do is to change this sign into a positive. Remember from this part where we had positive and negative, and we picked the negative one, so now we need to replace that with a positive. So we'll go 2 add the square root of 244 divided by 6. That gives us 2.936749892. Again, we need to write it to 3 significant figures, so 1, 2, 3, and 6 tells us that we've got to make the 3 a 4, so 2.94 is the answer. In question number 12, we've got the graph of a circle is x squared plus y squared equals 6.25. The radius of the circle is 6.25. Is this true or false? This is actually false, because 6.25 is r squared, the radius squared. So r is going to be the square root of 6.25. And I can quickly show a sketch here on the graph. So if I drew the circle with the center of the circle being at the origin, and this would be the radius. And we know through Pythagoras that the radius squared is going to be equal to y squared plus x squared. So the answer here will be false. In question number 13, we've got the graph of y equals fx is a quadratic with its minimum point at 2, -1. Write down the coordinates of the minimum point of the graph with the equation y equals fx plus 4. So I will very quickly sketch the graph, and we've got a minimum point at 2, -1, so about here. Two -1. Now what this tells me is that the graph has moved 4 spaces up. Whatever would happen within the brackets would show the movement across, whereas whatever is outside of it is how many spaces you've moved up or down. So that means moving 4 spaces up. So we go 1 to get to 0, 2, 3, 4. So this would be 3. So y would be equal to 3. So the coordinates would be 2, 3. The graph will have a shape like this. So use brackets and put a comma. We'd have it like this. And that's the final answer. The two solutions to 10x squared minus 43x minus 30 equals 5 are. Select one. So we have a multiple choice question here. But the way that I'm going to solve this, instead of just plugging in the values and see whether this works, is by trying to find the solutions based on the quadratic. There are different ways you can solve a quadratic, and one of them is factorizing. You could use the quadratic formula, complete the square, and so on. So I will try to factorize this. But first of all, I need to make this equal to 0. So I'll go 10x squared minus 43x. I've got minus 30 equals 5. So taking away 5 from both sides, then this becomes minus 35 equals 0. So we've got a coefficient of x squared being 10, and we've got c being minus 35. So we'll multiply these together, which makes minus 350. So we need to find two factors which multiply to give us minus 350, but also add to give us minus 43. So we'll try them out. Of course, it can be minus 350 times 1 or minus 1 times 350. And we can do minus 70 times 5. Or it could be minus 50 times 7. And this seems to be the right one, because adding 7 to minus 50 would give us minus 43. We'll open up the brackets, and I'll place minus 50 and plus 7 inside, and 10x on both of them for the time being. So I can factorize the first one by putting 10 in front of the brackets, but I will not put that. And we've gone through y in a previous question. So we'll make this now x minus 5. So both of the terms inside are divided by 10. And this one we cannot factorize, so we'll keep it as it is. And it does work because x times 10x is 10x squared. X times 7 is 7x. Minus 5 times 10x is minus 50x. Minus 5 times 7 is minus 35. So collecting the like terms, we now have 10x squared minus 43x minus 35. Now looking at the solutions, so we'll bring the brackets here. One of them is x minus 5, so this means that x is equal to 5. The other one is 10x plus 7 equals 0, so we make them both of the brackets equal to 0. We get 10x is equal to minus 7, so x is going to be equal to minus 7 divided by 10, so x is equal to minus 0.7. So we worked out the two solutions when x minus 5 is equal to 0 and 10x plus 7 is equal to 0, and that seems to be option D. In question number 15, we've got to find the equation of the line that is perpendicular to the line y equals 2x minus 5 and passes through point 3, 2. Write your answer in the form y equals mx for c. Use decimals and don't put spaces in your answer. So we need to find the gradient and the y-intercept. To find the gradient, we'll use the equation of this line. So we know that the equation of the line that we are after is perpendicular to the line y equals 2x minus 5. In order for it to be perpendicular, the gradient of it must be the negative reciprocal of the gradient of this line. So reciprocal of 2 is half, so the reciprocal of a number is 1 divided by that number, and negative, so we put a negative in front. So the equation of the line that we're looking for is y equals minus half x plus c, the y-intercept. We don't know the y-intercept, so we're going to use the coordinates that are given to us to work it out. So there is x and there is y, so we'll replace them, y being 2 and x being 3. Plus c. So 2 is equal to negative half of 3. Half of 3 is 1.5, so minus 1.5 plus c. So we get now, adding 1.5 on both sides, we get 3.5 is equal to c. So c is equal to 3.5. So I'll rewrite the equation of the line as minus 0.5x. So instead of the fraction, we're using a decimal. And we've got plus 3.5, which is the y-intercept, or c. Now in the next question, we've got for all of the values of x, x squared plus 6x is equal to, open bracket, x plus p, close bracket, all squared, plus q. In this part, we've got to find the value of p. So this is a case of completing the square. So I can rewrite this as x squared plus 6x is equal to, we'll have x plus 3, so half of 6, and that's all squared, taking away that number that we have here, squared, so the 3 squared. So this is then equal to x plus 3 squared minus 9. The value of p is 3, and the value of q is -9. Add the value of q as -9 in this follow-on question. Now we've got the same beginning of the question, the same kind of question, but it's a follow-on. Find the coordinates of the minimum point of x squared plus 6x. Write your answer as coordinates using brackets. So we've got the full equation being y equals x plus 3 squared minus 9. So the coordinates of the minimum point will be -3 minus 9. So the value or the sign in front of the 3 changed to become -3, whereas the sign in front of 9 did not change, so it remained -9. If you want to see as to why this happens, you can help yourself by sketching graphs. You can compare this to the x squared function. So typical x squared function more or less looks like this, and what this is telling us that what's happened to x is that it's moving 3 spaces to the left, so 1, 2, 3, and it's going down by 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. So somewhere here would be the lowest point. Now, clearly you can see there is a -9, but you're probably thinking, why did I go to the left if this is saying +3? Because the lowest point would be found if whatever is within the brackets is going to be equal to 0, because it can't be any lower than 0. A square number cannot be negative. So that means x is going to be -3. So -3 plus 3 is going to give us 0, and then take away 9. This is something that you can explore, and you can use Dismos graphing tools to try out different functions and see what happens each time when you change the values within the brackets and outside of the brackets. In question number 19, we've got to solve the inequality x squared minus 5x minus 6 is smaller than 0. So we'll treat this like a quadratic equation, and if it was equal to 0, what we do is we'd factorize it. So I'll open up the two brackets, two sets of brackets. So we've got x here and x on the other one. And we need to find two factors which multiply to give us -6 and add to give us -5. And that is -6 and 1. So x minus 6 and x plus 1. If we expand them, we can check that this actually works. So if it was a quadratic equation equal to 0, we'd have x minus 6 equal to 0, and that means that x would be equal to 6. We'll do the same here now, and we've got x plus 1 equal to 0, and x will be equal to -1. But these are what we call the absolute values in this case, because of course this equation is not equal to 0, but it's smaller than 0. So what we're going to do is quickly we'll sketch this, and we've got x equals to 6 and x equals -1. So if we quickly sketch this, it's going to look something like this. Now we're interested in the part that is smaller than 0, which is this one here. So this now is in between -1 and 6. So x is greater than -1 and smaller than 6. So that's what we need to write within the space provided. Now we've got to solve these simultaneous equations. As you can see, both of them equal y. So what I'm going to do is I'm going to rewrite this as x squared minus x minus 13 is equal to x plus 2. Taking away 2 both sides, we then get x squared minus x minus 15 is equal to x. And taking away x both sides, then we get x squared minus 2x minus 15 is equal to 0. So we're going to solve the quadratic now. So factorizing, finding 2 factors that would multiply to give us minus 15, that would be minus 5 and plus 3, because if we add 3 to minus 5 as well, it's going to give us minus 2. So we get x minus 5 and x plus 3. The positive value, this means that x is equal to 5, and this means that x is equal to minus 3. The positive value is 5. So that's the negative value in the question that asks for it. Now we've got another question which says, give the positive y value. So we've got to write the positive y value based on the answers that we have for x. So we had 2 values for x, minus 5 and 3. So these will match with some values for y. So when x is minus 5, y is equal to minus 5 plus 2. So I'm just using one of the 2 equations that we have in there. The second one is easier, so I'm going to use that. So minus 5 plus 2 gives us minus 3. So y is equal to minus 3 when x is equal to minus 5. And when x is equal to 3, y is equal to 3 plus 2, which is 5. So give the positive y value. The positive y value is 5. And there is a follow-up question which is going to ask for the negative value of y. I'm going to input now. So we'll add minus 3 in this question, which is about the negative y value. In the next question, we've got for all values of x, fx is equal to, or f of x is equal to x squared plus 3x, and g of x is equal to x plus 5. We've got to find fg of x. What this means is that the f of x that we have, which is x squared plus 3x, will replace the x's with x plus 5. The order is given by f being first and then g being second. So we'll incorporate the g of x within the f of x. So I'll rewrite this as, instead of x squared, we'll put x plus 5 all squared, plus, instead of 3x, we'll put 3, and then x will be replaced with x plus 5. So this can be now expanded. So x plus 5 times x plus 5 is x squared plus 5x plus 5x plus 25 plus, now expanding these two, we get 3x plus 15. Collecting the like terms, we get x squared plus 5x plus 5x is 10x plus 3x is 13x. 25 and 15 is 40. So this is the final version of it, but we'll write it with this symbol on top of x as requested here. So this is what should be input in the computer. And we get 2 plus 13x plus 40. So this is only because Moodle requests this to be written this way. Otherwise, on paper, this would be the right answer. In question number 25, we've got to find a formula for the nth term of this quadratic sequence, which goes 3, 7, 13, 21, and so on. So the difference between 3 and 7 is 4. Between 7 and 13 is 6. Between 13 and 21 is 8. So we add in different amounts each time. And the difference between 4 and 6 is 2. 6 and 8 is 2. And it would be for the next one as well, 2. So the difference of the difference remains the same. Now this tells us that this is a quadratic sequence, and we're told in the question as well that this is a quadratic sequence. So it must start with, the nth term must start with n squared. So n squared means square numbers. So we'd have numbers such as 1, 4, because 2 times 2 is equal to 4. And then the third square number is 9. The fourth one is 16. So what I want to do is take away these square numbers from the numbers we had at the top, the numbers we had in the sequence. So 3 take away 1 gives us 2. 7 take away 4 gives us 3. 13 take away 9 gives us 4. 21 take away 16 gives us 5. So we've removed the n squared. Now what is left is a linear sequence. So we'll treat this as a linear sequence. And what happens? Let's see. From 2 to 3 we add 1. From 3 to 4 we add in 1. 4 to 5 we add in 1. So this must be n. So 1n. So I'll add this to the nth term. So we add in 1 each time. So we're saying n. Now we've got to go back a step to see what would be the 0th term. And this would be 1. So reversing that process, taking away 1. So the nth term for this sequence would be n plus 1. So I've added that to the nth term for the quadratic sequence. So n squared plus n plus 1 would be the nth term of the quadratic sequence. So we'll write this as n squared plus n plus 1. The final question, we've got to find the inverse function where f of x is equal to 2x minus 3. So what this means, we're going to look at reversing the process. So 2x minus 3, if we, for 1 second, we just assume that x was equal to 1, then we'd have 2 times 1 minus 3, which is minus 1. If x was 2, for example, then we do 2 times 2 minus 3, which gives us 1. If f is 3, we can do 2 times 3 minus 3, which gives us 3. So this gives us particular values if we input values for x. So what we're going to have to do is just reverse the process, which is no different from actually making x the subject. So what we've got is f of x, which we're going to denote with y in this particular case, is equal to 2x minus 3. So adding 3 both sides, then we'd have y plus 3 is equal to 2x, and then we'd divide both sides by 2, so we get x on this side and y plus 3 all over 2 would be the value for x. So the only difference though is that we're gonna swap the x's and the y's around, because our x, as in the position that it has now, would be the actual answer, whereas this one here would be what we want to work out, and that would be x. So we'll write this as x plus 3 over 2 is equal to y. And in the space provided, we can do it as x plus 3, because it's the whole thing that's being divided by 2.